Earthquakes are important for people to study, mostly to figure out anything that may be important later we don't know about yet. If you're measuring earthquakes in an area that you know is going to have them, you can put them out in a really fine grid or put them very far apart and do a gross approximation of things. And you should tell people that when you present the information. Just like measuring the weather patterns, there isn't a weather station every mile of the surface area of the United States. At one point or another, there may be dozens of them because a bunch of people put out open-sourced, anybody can view it, weather data from their house. But they're not in a grid pattern. So over here, where there are a lot of people or a lot of dead space with a bunch of, equipment, you may have a nice grid that's a nice XY pattern, or it may be tilted at a funny angle, or whatever. And what you're supposed to do is you're supposed to take the data in and figure out, okay, I have two pressure changes over here that match each other, but over here they're different. Should I make it two blotches, blotch method, or should I connect them because they're identical? And the answer is yes. One or the other will be more appropriate depending on what's going on when you look at the others. Same thing with earthquake monitoring. You have to do this almost as often as you do air pressure changes to try to figure out what the hell's happening with the weather. And when you do that, you're getting individual point sources. Over here, you could have a whole cloud of like 50. Over here, you could have just 2. That's the same way you do it for air pressure changes, temperature, wind speed, humidity, rain gauges. And when you do this, that will create a weird pattern. And every news agency, every newscaster in an area, every year or so should tell everybody how we detect weather changes and point out that they're not evenly distributed. And in some areas, there are no sensors, which is bad. When it comes to earthquakes, however, when you look at the websites, they're supposed to do something simple. Earthquakes, almost always, but not always, are based on a single point somewhere on a map and at a certain depth having an earthquake. But what if you're dealing with a volcano and you're trying to figure out where it's going to crack next and you put it up on your website? Well, you could tell the software not to try to figure out where the earthquake is and create a hotspot map. Now, again, it could be caused by where you have your sensors, but in this case, we're talking about a website that took information in from an unevenly distributed set of sensors. Don't assume it's evenly distributed. Maybe evenly distributed, but let's assume it isn't. They then take it into a piece of software that tries to approximate where the earthquake is happening. Now, instead of just giving you a pinpoint, it presented it almost like there was a perfect grid of sensors. And you get a pattern of hotspots instead of a pinpoint or a thumbtack or whatever in the map where the earthquake is happening. It presents you with a almost attempt at being raw information where it would show you a bunch of sensors, but that's not where they're positioned. Not necessarily, anyway. Now, the same kind of aberration that looks artificial because it's a computer routine presenting it to you in an artificial way, an artificial intelligence routine interpreting the natural world is going to look artificial. And yes, I just typed that out badly. And let's say it's a weather phenomena. Well, you're using, let's say, radar. Radar, by definition, makes little sweeps using a piece of equipment and makes a circle. And every once in a while, people will look at raw-fed information of radar showing where cloud patterns are or air pressure changes, and they'll notice suddenly a little circle form. And I'm going to assume it's caused by the radar dish because it's spinning in a circle, and it might have made an error and decided that everything's bouncing from a certain distance because it's gone cuckoo for a couple of seconds. Or B, that's an example of a ray beam from space because it's, HARP. The second assumption is a great way to have an excuse to put up a YouTube video or a post on Facebook and be famous. The first assumption is what's actually causing it. It's an aberration in the way that the radar is being interpreted by either software or hardware. That's it. One really good example is they did a cloud pattern, really nice cloud pattern, but right in the middle there was a zero that would form, strangely, right around a radar dish. It's because the data cut out, and because it didn't provide data, they just drew it as a hole in the map. Yeah, because it's an unreliable dish. In the case of the website you might have found this video associated with, they are presenting information, not trying to figure out exactly where the earthquake is. This is preliminary looking data, and it still has that weird gritty effect that has been applied to it by the computer routines doing their first layer gross calculation. The specific thing is approximately 1 kilometer resolution approximated for 2 digits of latitude in the area, instead of rounding it off to 3 or 4. Now remember, this is all just based on the software trying to do a decent job. This is like taking a photo of me and putting it in halftone, where it's a bunch of dots. Well, he looks like a cloud of dots. That's called halftone. That means you're taking a perfectly good image and presenting it in a really crappy way because it saves ink. In this case, it's almost the same thing. And that's the whole problem. So what you're dealing with is a piece of software, we can call it an AI program, trying to interpret reality and doing a half-assed job of it, and the website presenting it as is because it's good enough. It allows them to detect that individual earthquake, and you'll have a bunch of little dot patterns that are impressed over the image. And if there's a crack forming and you get a line, you'll get a bunch of dots that are bigger and a bunch of little dots off to the side. My opinion is if it's an earthquake occurrence around an active volcano, this is understandable. If it was for, a crack in the earth like they have in California, they generally just do pinpoints because that's more important than useful. Anyway, this is caused by data interpretation again. No, it's not a sign of artificialness. It's an artificial interpretation because it's done by a piece of software of a natural event that it's getting confused by. This happens all the damn time. We call it computers suck. Thanks for watching. Have a good day. Good luck.